Hello everyone. In the last session, I explained molarity. In this session, I am going to explain normality. So, what is the normality? Here, the number of gram equivalents. What I am saying? The number of gram equivalents present in 1 liter of a solution at given temperature is called as normality. The normality, the number of gram equivalents present in 1 liter of a solution at given temperature is called as normality. Here the normality also depends upon the temperature. Why the normality depends upon the temperature? In the normality principle, the volume term is there. This volume changes with the temperature. Therefore, the normality also changes with the temperature. Here, the normality equals to number of gram equivalents by volume of solution in liters. Here, the units of the normality is equivalents per liter. Equivalents per liter. And here, number of equivalents equals to weight by gram equivalent weight. 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 Therefore, normality equals to weight by gram equivalent weight into 1 by V, that will be in liters, the volume of solution in liters. Next, the volume is taken in milliliters, then normality equals to weight by gram equivalent weight into 1000 by V, that will be in ml. Here, the gram equivalent weight is different for the different substances. Different for the different substances. So, in case of acids, what I am saying? In case of acids, the gram equivalent weight equals to gram molecular weight by basicity of acid. Basicity of acid. What I am saying? The gram equivalent weight equals to gram molecular weight by basicity of acid. Here, first we know what is the basicity. The number of replaceable hydrogen atoms. What I am saying? The number of replaceable hydrogen atoms present in 1 molecule of acid is called as its basicity. Let us take HCl. In HCl, how many replaceable hydrogen atoms are there? Only 1 is there. Therefore, its basicity is 1. Similarly, in case of sulfuric acid, the number of replaceable hydrogen atoms is 2. Therefore, its basicity is 2. So, in case of HCl, the gram equivalent weight equals to GEW equals to M by 1. And in the second case, that is gram molecular weight GMW by 1. And in the second case, the gram equivalent weight equals to GMW by 2. GMW by 2 means in case of HCl only 1 replaceable hydrogen atom is present. Therefore, its gram equivalent weight equals to GEW equals to gram molecular weight by 1. In case of H2SO4, gram molecular weight by 2. But in case of H3PO4, in case of H3PO4, the basicity is 3. Therefore, gram equivalent weight equals to gram molecular weight by 3. Gram molecular weight by 3. Why? Because it contains 3 replaceable hydrogen atoms. And similarly, if I take H3PO3, the basicity is 2. Therefore, gram equivalent weight equals to gram molecular weight by 2. In case of H3PO2, the gram equivalent weight equals to gram molecular weight by 1. Why? Because base heat is 1. If you observe the H3PO4, H3PO3 and H3PO2, phosphoric acid, phosphorus acid, hypophosphorus acid, all three acids contains 3 hydrogen atoms in its formula. But in case of H3PO4, the base heat is 3. In case of H3PO3, base heat is 2. And in H3PO2, the base heat is 1. So if you know the structure of these acids, we know very well about the base heat. In case of H3PO4, if you observe the structure of H3PO4, it have 3 OH groups. So the number of replaceable hydrogen atoms are 3. But in case of H3PO3, the number of OH groups only 2. Therefore, the number of replaceable hydrogen atoms is only 2. Here one hydrogen directly linked to the phosphorus. Therefore, that hydrogen does not undergo ionization. So therefore, the base heat is 2. In case of H3PO2, the base heat is 1. Why it is 1? Because it contains only one OH group. Therefore, its base heat is 1. So it means the basicity of acid depends upon its structure or its nature, but not on the basis of the formula. In all 3 cases, they contain 3 hydrogen atoms in their formula. But in the first case, the base heat is 3. Why? Because it contains 3 OH groups. In the second case, it contains only 2 OH groups. And in third case, it contains only 1 OH group. Therefore, base heat is 1. So, gram equivalent weight equals to gram molecular weight by 1. GEW equal to. So, this is in case of acids. And in case of base, the gram equivalent weight equals to gram molecular weight by acidity of base. Acidity of base. Here, acidity of base means the number of replaceable OH groups present in a one molecule of base is called as acidity of base. For example, if you take NaOH, in NaOH the number of replaceable OH groups is 1, or we can say in another way, one molecule of NaOH reacts with the one molecule of monobasic acid, that is HCl. Here, how many replaceable OH groups are there? Only one replaceable OH group is there. Therefore, its base heat is 1. Therefore, gram equivalent weight equal to gram molecular weight by 1. Therefore, gram equivalent weight equal to gram molecular weight by 1. In case of calcium hydroxide, number of replaceable OH groups are 2. Therefore, gram equivalent weight equals to gram molecular weight by 2. Similarly, in case of salt, the gram molecular weight by or formula weight by, in case of ionic compound we can say formula weight instead of the gram molecular weight, by total positive or negative charge. Similarly, in case of redox reactions, the number of electrons involved in a reaction, the gram equivalent weight equal to gram molecular weight by number of electrons involved in the reaction. So simply what I am saying, the gram equivalent weight equals to GEW equals to GMW by GW equals to GMW by Z. Here what is Z? In case of acid, basicity. In case of base, acidity. In case of salt, total positive or negative charge. Positive or negative charge. In case of base, it is positive or negative charge. In case of redox reagent, change in the oxidation number. Oxidation number or number of electrons involved in the reaction. So this is in case of a redox reagent. So everyone should remember, in case of acid, gram molecular weight by basicity. In case of base, gram molecular weight by acidity. In case of salt, gram molecular weight by total positive or negative charge. In case of redox reagent, change in oxidation number. Already you are studied in the first year in psychometry chapter. Next, in case of normality, here also we can apply the dilution law. In case of dilution law, N1V1 equals to N2V2. N1V1 equals to N2V2. And similarly, the amount of water to be added, delta V equals to V2 minus D1. Everyone should remember this equation. And similarly, if the two acids are mixed together or two bases are mixed together, what I am saying, either two acids are mixed together or two bases are mixed together, don't mix the acid base. So in that case, the normality of resultant solution equals to N1V1 plus N2V2 by V1 plus V2. So this is for mixed solution. Either you take either acid or base. Okay. Next, if we mix the acid as well as the base, here you have to remember the three conditions. First condition, NEAVA equals to NBVB. In that case, the solution is neutral. Generally, the pH of the solution is 7. But if NEAVA greater than NBVB, that solution is acidic. And the resultant solution having the more H plus ions. Therefore, H plus ion concentration equals to NEAVA minus NBVB by VA plus VB. This is condition 2, that is NEAVA greater than NBVB. In that case, what is the nature of the solution? Acidic nature. In that case, H plus ion concentration equal to NEAVA minus NBVB by VA plus VB. Similarly, third condition, if NBVB greater than NEAVA, in that case, the solution is basic nature and the pH of the solution is more than 7 generally. And here the resultant solution have the OH minus ions. Therefore, OH minus ion concentration equals to NBVB minus NEAVA by VA plus VB. So everyone should remember these three relations. So this is for dilution law. Here this is for mixed solution of either acids or bases, and this is condition is if NAVA equal to NBVB. So what is the nature of the solution? Generally neutral. And the third condition, if NAVA greater than NBVB, what is the nature of the solution? Acidic nature. Therefore, the resultant solution having the H+ ion concentration or H+ ion. Therefore, H+ ion concentration equals to NAVA minus NBVB by VA plus VB. And that is the normality of the resultant solution. And similarly, normality of the resultant solution nothing but a basic nature. Therefore, OH minus ion concentration equal to NBVB minus NAVA by VA plus VB. So, in the examination point of view, the normality is very important. And similarly, if you observe the JEE mains and advanced papers, some question was asked on the relation between the molarity and normality. Here, everyone should remember normality equals to molarity into Z. Here, what is the Z here? In case of acid, basicity. In case of base, acidity. In case of salt, total positive or negative charge. In case of redox reagent, change in the oxidation number or number of electrons involved. Let us take one simple problem on this equation. Here, the molarity of H3PO4 equals to 1 m. And what is its normality? Here, what is the basicity of H3PO4? 3. Therefore, Z value is 3. Therefore, normality equals to 1 into 3. Therefore, 3n. This is a simple question, previous question. So, everyone should remember this type of problems. Thank you. In the next session, I am going to explain solubility and Henry's law. So, this is concentration methods are very important. So, what are the concentration methods? Mole fraction, molarity, molarity and normality. Thank you.